Okay, so going over some of the work we did yesterday, which was solving simultaneous equations by elimination. And this is a pretty difficult topic, solving simultaneous equations, so let's have a look at a couple. Now, when you solve simultaneous equations by elimination, you need to follow the following procedure. Your first step is make one of the variables, which is the pronumerals, the same size in both equations. And the second step is to eliminate this variable by either adding or subtracting. And yesterday we said if they have a different sign, you add them. But if they have the same sign, you subtract them. So let's have a go at one or two. Now, I'll first have a go at question 4b. So my two equations are, this is question 4b, 2x plus 7y equals 9, and 2x plus 5y equals 11. First thing you do, call that equation number 1 and call that equation number 2 so you can tell the person looking at your work what you're doing. And straight away, I don't need to make the variables the same because I can see that the x is the same size in both equations. And there's a positive sign in front of both of these. So they have the same sign. So I'm going to subtract these equations. And it doesn't matter which way I subtract them, I'll still get the right answer. But I like to go the bigger one, the bigger pronumeral, so I get a positive pronumeral, minus the small one. So I'm going to go equation 1 minus equation 2. Equation 1 minus equation 2. Now, 2x minus 2x, well, that eliminates. It goes. 7y minus 5y gives me 2y. And 9 minus 11 gives me negative 2. And then I just divide by 2, and I get y equals negative 1. Now, I haven't finished. I've now got to substitute that back into either of the equations to find the x value. I'm going to sub it into equation, doesn't matter which one I do, 1. So 2x plus 7, now I know that the y is negative 1, so I'll put in the negative 1, 7 times negative 1 equals 9. So I get 2x minus 7 equals 9. I add that 7 across and I get 2x equals 16. I divide by the 2 and I get x equals 8. Now I have an answer which is a coordinate 8 is 1, 8, x is 8, and y is negative 1. Just to make sure, I'm going to check. Now, I can't check that in equation 1 because that's where I got it from, so I'm going to check in equation number 2. So, does 2 times 8 plus 5 times negative 1, well, 2 times 8 is 16, minus 5, which equals 11. And that is correct. So I know I'm right. Now that was pretty easy because we didn't have to do anything great there, and it was easy just subtracting. But let's have a look at another one. Let's have a look at 5b. So let's have a go at 5b. Again, I'll write down the two equations. So I've got, oh, this is going to be hard. Minus 5x plus 3y equals negative 1. Actually, and minus 5x plus 4y equals 2. Call that equation number 1. Call this equation number 2. Now again, I don't have to make the pronumerals or the variables the same size because they're both 5x. And again, they've got the same sign. It's negative and negative. So I'm going to subtract these equations. Now this time, I'm going to do equation number 2 minus equation number 1 because I'm going to get 4y minus 3y. And I'll just get rid of the negative. So, negative 5x minus negative 5x, well, that eliminates. Now remember, I'm going from equation 2 and subtracting equation 1. So I've got 4y minus 3y, and that just equals y. Be careful with this last bit. I've got 2 minus negative 1, and that becomes 3. So straight away, I've got my first solution, or my first part of the solution, the y value. I'm going to sub that into either of the equations. I'm going to sub it into equation number 1. And I get minus 5x plus 3 times 3, because I've put the 3 in for the y, equals negative 1. Minus 5x plus 9 equals negative 1. I minus that 9 across, and I get minus 5x equals negative 10. And I divide by the negative 5, and I get x equals 2. So my solution is 2, 3. But I want to check that, and I'm going to check. I used 1, so I'm going to check in 2. Does it work? Well, does 5 times, or negative 5 times 2, plus 4 times 3, well, what does that equal? That equals negative 10 plus 12, well, that equals 2. And that's correct. So no, my answer is correct.